On this DeBacco University video, I'm going to go over measuring light wavelengths, which might seem a little complicated. So I'm going to go something you probably haven't done before as well. So I'm going to go over some of the details here on how we go about measuring light wavelengths. All right, when it comes to measuring light wavelengths, we want to look at a quantitative spectroscope. These are designed to separate light into a very wide spectrum of colors to make it easier to see. We kind of look at it here. This allows you to make a quantitative comparison of different light sources. So when you look through, this is what they look like. Look at the black triangle. Essentially, there's a small area here, small slit where it's allowing some light to come in. It's basically being separated and you're looking at this area here. So this is where the light's coming in, but you're looking over at this area. And this is able to see those different bands of different colors. In a little comparison, it's a little hard to get a good picture, but daylight, LED lights, fluorescent, and incandescence will all give a different spectrum. We can kind of see the differences here. Now they'll always be in the same order. We could see that there's definitely the fluorescents have a much more limiting spectrum than say daylight, where you could see a much more wider spectrum across many wavelengths. There's also a photometer, as the name implies, photo meaning light. This is an instrument that measures the strength of the electromagnetic radiation in the range of ultraviolet to infrared, including the visible spectrum. So remember, the electromagnetic spectrum is quite broad. We're looking at really during that light visible spectrum plus or minus a little bit. There's something called a Photometer. So a Photometer is a device that measures light that's basically from the sun or artificial lights. It's really used to see what the plants are receiving as far as light. What is the area? What is the PAR stands for the photosynthetically active radiation. And what that means is that's basically the portion of the electromagnetic spectrum, or the wavelengths of light, that plants are able to utilize. Pretty much defined as the 400 to 700 nanometer wavelength spectrum, which is the spectrum of light that plants can most readily utilize. Yes, they might use a little bit below and above that, but when we're looking at a PAR reading, that's the area we're talking about. Then the Spectr Photoometer here, it's a highly specialized piece of equipment used to measure how much a chemical substance absorbs light when a beam is passed through it. So here we see a light source, we see a lens. We basically have our wavelength selector. In this case, we're using the yellow wavelengths. And we've got our sample, and we're detecting here how much. This is great to see how much a compound absorbs or transmits light over a certain range of wavelengths to give us a concentration idea. And this is utilized within the scientific research. Again, the reason why you have to close this to eliminate outside wavelengths of light, but this is seeing how a simple piece of equipment can be utilized to really look at the light and be able to separate out into wavelengths, to more sophisticated electronics, to here utilizing wavelengths of light to look at how a sample might absorb, transmit certain wavelengths to determine its concentration.